Hello, this is Ms. Shelns making this for Pre-Calculus Honors at Boston Collegiate. So welcome, this is our, this is part one of our Unit 8 solving trig equations. So you probably want this out in front of you. If you don't, you can just copy it. If you don't have this, you can just copy along as we go. So write in the date here. Okay, so let's get started. This unit is on solving trigonometric equations. So we're going to use in this PowerPoint, we're going to break it up into 4 parts, and it contains the following 4 strategies and concepts: factoring, extraneous solutions, other solving methods, and then altered argument equations. All right, so let's start here with primary values. So this is a vocab term that means the following. So in these problems, we'll be solving for primary values of variables. So primary values means all of the values between 0 and 360, including 0, not including 360, or between 0 and 2 pi. Okay, so the directions could read like this: solve from, and it gives you the domain, or it could say solve for primary values. It could say that too, in which case, and if it doesn't specify degrees or radians, you can choose. So we have these 2 equations, we're going to solve them. So you just kind of have to think backwards for this. Okay, so cosine theta equals negative root 3 over 2. So what I suggest is first starting with the quadrants, okay, and then what the reference angle is, and then go from there. So the quadrants where cosine is negative, if we just go with all students take calculus, we know it's positive in first and fourth, so therefore it's negative in the second and the third. All right, and the reference angle, so these are, if you've forgotten all these values, you need to know them for this unit, like you need to. All right, so I do know them. So we're not going to go over how to find them again. That's on you, but this is 30 degrees. So I'll write somewhere alpha equals 30 degrees. That's how I indicate my reference angles. And then so I know that in the second quadrant, it's 180 minus alpha to get my second quadrant angle. And in the third, it's 180 plus alpha. In the fourth, it's 360 minus my reference angle, gives me my fourth quadrant angle. So this would be 150 degrees, and this would be 210 degrees. Okay, so those are the primary values for which this equation holds true. We know, of course, that there's infinite number of places. So if I did plus 360k, specifying that k is an integer here and here, that would be how I do infinitely. But we're not going to do that for this unit. All right, so let's do this next one. Tangent x plus 1 equals 0. So this isn't a quadratic, so I actually don't want it equal to 0. So I'm going to subtract 1 from both sides. Tangent x equals negative 1 to make it look like this guy up there. So now you just have to think about, where's tangent of x equal to negative 1? So we have our 2 things we got to consider. We had a graphic organizer for this on a colored piece of paper way back when, if you want to refer to that. But so you need your reference angle and you need your quadrants. If it's not a quadrantal angle, it's going to be 2 quadrants always. So tangent is negative. Think about which, so take a second, think about which quadrants tangent is negative in. Alrighty, tangent is negative in Q2 and Q4. All right, now take a minute and think about what the reference angle for tangent theta equals negative 1 is. So basically you want to think, where is tangent equal to 1? So just come up with the acute angle between 0 and 90, where such that tangent of that angle is 1, and you can do it in degrees. All right, so you should have gotten 45 degrees. Just to do an example in radians, I'm going to do this one in radians. So that's pi over 4. Okay, so go ahead and name my 2 answers. Name my 2 answers in radians. So go ahead. Okay, so it would be pi, this one is pi minus pi over 4. So my Q2 angle is 3 pi over 4. That's 4 over 4 minus 1/4. My Q4 angle is 2 pi minus pi over 4. So it's 8/4. So this is 7 pi over 4. Okay, so we just, we're solving trig equations already. First thing, we've already solved 2 trig equations, one in degrees, one in radians. To summarize our processes, we need to figure out 2 things up front. We need to figure out our reference angle and our 2 quadrants. If it's quadrantal angle, like sine equals 0 is 0 and 180, like 180 is a multiple of 90, so it's a quadrantal angle. That's a different process, but let's move on. All right, seen another way. So you're gonna do this one in degrees. So this is kind of like the same question worded a different way. And then we have this other term, principal value. So this means primary values, primary, okay? Principal value means acute, okay? Yeah, we'll go with that. Well, it means acute. It means like the first positive angle. So I guess another way to say it is the first positive angle. That's what principal values mean. So inverse sine of root 2 over 2, find the principal value. You might be able to just think about this as is, but I'm just going to copy it down to show how it's similar to the last example. So let's say I have this equal sum output, some x, right? If I take the sine of both sides, then the sine on this cancels out, and I just take the sine of this, so this equals sine of x. So basically it's like sine of what angle equals root 2 over 2. And yeah, we'll do this one in degrees, we'll do the next one in radians. So go ahead, answer that question for principal value. Okay, find the principal value that for which this equation is true. Okay, so 45 degrees is where that's true. And then principal value is just that first angle. You don't have any others. All right, let's do this one. So inverse sine of negative root 2 over 2 from 0 to 2 pi. So this indicates that I have to solve in radians. Okay, so I'm not going to rewrite this. I'm just going to think of this as the same problem where I figure out my quadrants and my reference angle, and then I'll have multiple answers. I'm going to give you a clue. We're going to have 2 answers, okay, in radians to this problem. So I'm going to give you some time to reflect. So again, figure out the 2 quadrants, all right, and then the reference angle, and then figure out then the answers. All right, go ahead. All right, we're going to come back together and do it. So sine is negative in Q3 and Q4. The reference angle is 45 degrees, or pi over 4. So this would be 5 pi over 4 and 7 pi over 4. That's the correct answer that you should have gotten. All right. All right, this one is a different kind of example. So this has 2 functions, and we work from the inside out of the parentheses. So you could say, what is the inverse cosine of this? And then take the cosines of that. All right, but what do we know about inverse operations? They undo each other. They cancel out. So I can just do that, and my answer is that. Negative root 2 over 2. Simple as that. So it's a quick problem. So no angles involved, they just canceled out. Also, just so that you know, it works the other way too. If I had this, okay, this is also negative root 2 over 2. All right, we have 5 more examples, 2 more slides to go. All right, so these look like more like equations. I'm gonna zoom in a little bit. All right. Okay, so solve from 0 to 360, and our calculator is active on this one. All right, so I'm gonna start by isolating the variable by getting it alone. So if you want to rewrite this, you can think of it as cosecant theta squared equals 9. All right, so basically you have 2 cosecants, not 2 thetas. you have cosecant times cosecant. So I'm going to square root both sides to start solving. Cosecant theta equals, now I just made a mistake. What mistake did I make? I need to add in a plus or a minus. All right, I need to add in a plus or a minus. So, okay, my calculator doesn't even have a cosecant button. So what do I do about that? I'm going to change cosecant to sine. So I'm going to say 1 over sine of theta equals plus or minus 3. Okay. I'm going to say 1 over sine theta equals plus or minus 3. I'm going to then take the reciprocal of each of those. So sine theta equals plus or minus a third. Okay. So now to solve, I do just like before, where I figure out quadrants and reference angle. So this is plus or minus. So it's just going to be all the quadrants: Q1, Q2, Q3, and Q4. I'll write in my. So I'm going to have 4 answers: 2 positives and 2 negatives. 2 that would have an output of positive 1/3, and 2 that would have an output of negative 1/3. So think for a sec, how would you solve this to get my alpha, my reference angle? Yeah, you would enter this into your calculator. You don't need to do the plus or minus, but you would take the inverse sine of a third. Okay, so what you're going to do right now is you're going to have your calculator. We want it to be in degrees, so check your mode on your calculator to be in degrees, okay? Otherwise your answer won't make sense. And take the inverse sine, and that's your that's going to be your reference angle, and then figure out the 4 angles from there. So go ahead and do that. Alrighty, and we're back. I don't know what it is, 'cause I haven't done it out yet. I don't have my calculator on me. But, yeah, so there you go. Let's move on to this one. Sine theta equals negative 2/3. So from here, right away, you can take the inverse sine of both sides. All right, and then figure out the quadrants. Since it's just negative, there's just going to be 2 quadrants. Figure out the 2 quadrants. So to figure out your reference angle, you would take the inverse sine of both sides. Now, if you take the inverse sine of a negative 2/3, it's probably going to give you a negative angle. So if you think about, I just want to explain why. If you just enter into your calculator, like go ahead, enter in real quick. Why do inverse sine of negative 2/3? Okay, you get an angle that's negative, so it's here in the. So a negative angle is here. So you get a negative acute angle, so it's here, negative acute angle. So if I were to graph it, it looks like this. This is the same, this is a quadrant 4 angle, okay? But to follow the convention from 0 to 360, I would need to add 360 to this to get the same, the coterminal angle, okay? So you have 2 options when you use your calculator. You can take the inverse sine of negative 2/3, get your negative angle, and then add 360 to it. Or you can just actually ignore the 2/3, the negative. Just do inverse sine of 2/3, get a reference angle, and then go ahead and find the quadrants. All right, so I'm gonna have you finish this problem on your own. You're gonna have 2 answers in the 2 negative quadrants of sine, and you use your calculator to find the reference angle. So go ahead and do that. Alrighty, and we're back. All right, thank you very much. Let's move on to this guy. All right, so solve for 0 to, so same directions, but this time I don't have a calculator. All right, so this problem, let's read it. 2 sine squared theta minus 1. It's not dissimilar to this one. So see how this one, I actually didn't want it set equal to 0 because I wanted to take the square root of both sides. This is going to be similar. So let's do this together. Okay, so I'm going to add 1 to both sides. Okay, divide by 2. I'd be like, oh, cool, sine a half. I know that is 30 degrees. That's a thing. But wait, sine's not isolated. I need to take the square root of both sides. So sine theta equals, when I take the square root, plus or minus the square root of a half. Like that. Oof. So this you probably don't recognize because I don't have a calculator, so I must recognize it as one of my values. It's either 0, 30, 45, 60, or 90. So I need to get it in a form that looks familiar. So I'm going to keep going here. I'm going to just distribute this like that. Okay, so this is basically plus or minus 1 over root 2. So now to make this look more familiar, I'm going to rationalize. All right, so let's rationalize here. 1 over plus or minus 1 over root 2. I'm going to times by root 2 over root 2. So this is plus or minus root 2 over, and then what's the square root of 2 times the square root of 2? It's just 2. All right, you could think of it as square root of 4, which is 2, either way. So you might be like, oh, cool, this is my answer. It's not my answer. This is what sine theta equals. So sine theta equals this. All right, so I need to figure out where does sine theta equal this. So go ahead. You're going to do this on your own. Think about your quadrants. Okay, think about your quadrants and your reference angle, how many answers you'll get, and go ahead and answer it. All right, go ahead. Alrighty, and we're back. So it's all 4 quadrants. Reference angle is 45. So 45, 135, 225, and 315. Okay. All right, these examples are sort of paired together. Last big example. All right, so I'm just going to recall factoring for this one. So go ahead and factor this with x's. All right, and we're back, so you should get x minus 4, x plus 1 equals 0. Okay, if you solved it, you'd get x equals 4 and x equals negative 1. All right, if you solved it. Let's see. So now we're going to factor this with cosines in it. Okay, so you could do 2 different things. You could say on this side cosine theta equals x, okay, and always rewrite it like this. So this is it's pretty intimidating, to be honest, you know. It's pretty intimidating looking at this. So you can always rewrite it with x's and then solve it with x's. But you can also think of it as cosine times cosine. Like, how do I get cosine squared? Which is cosine times cosine. And then it's going to just be minus 4 and plus 1. Again, multiplication is commutative, so you can put that in the other order if you got the other order. That's no problem. Okay, so now instead of x equals 4, I'm going to have cosine theta equals 4. Okay, I skipped a step. You could write cosine theta minus 4 equals 0, but for the zero product property, but we're just going to do this. Okay. So now let's think about where there's answers to these. All right. Let's solve these. So cosine theta equals 4. We're going to think about the range of cosine. We'll do it graphically. This is cosine theta. This is 1. 4 is up here. Cosine theta is never 4. So this has no solution. Okay. Cosine theta equals negative 1. So does this even, that doesn't, by the way, this doesn't mean that there's no solution to the whole problem because I have 2 equations that each may have solutions. So that just means this one has no solution. But this one might, and slash it will. All right, so cosine theta equals negative 1. So think about, is negative 1 even in the range of cosine? Yes, it is, because cosine goes from negative 1 to 1. This is some of the reasons we talk about the range of functions so much. It comes up, you know. So this is not one of our 30, 45s, or 60s. This is not a reference angle type problem. It's not like root 3 over 2. It's not root 2 over 2. It's not a half. It's negative 1. So that means it's a quadrantal angle. This is my hint that the answer is going to be 0, 90, 180, 270, or 360, or some combination, actually not 360 because that's not included. So either 0, 90, 180, or 270, or some combination thereof. So go ahead, solve this problem out. All right, and we're back. Theta is 180 degrees. That's all I need to circle as my answer. I don't need to do anything with that because it didn't yield any solutions, so I can just ignore it. So how you figure this out, that it was 180 graphically, you could think right here is where the output's -1, so that input would be 180. You could also think of your x, y, and r definition, so you know it's x over r is cosine. So my x value is -1. So you need an x value of -1 over r, which is 1. There's other ways to, those are the two primary ways to think about it. All right, so thank you very much, and I will see you next time. Bye-bye.